Hello, this is Professor Olmos. I wanted to at least explain how confidence intervals are calculated. So, on average, it all starts with a question, and you want to pose this question. This is an example. On average, how many pets do Cal State LA students own? And you have a couple of options. You have an option. The first option is ask every student how many pets they own. Option B, ask a sample of students how many pets they own. Now, option A is too costly and too time consuming, and you don't have those resources to do that. Option B is much more simpler, much more practical, easier to do. So we're going to pursue option B, but it's going to be an estimate. We're not going to be as precise as option A, but it's going to be an estimate. All right, so we ask, let's say it's 8 students from Cal State LA, how many pets they own, and they give us these answers: 2, 1, 4, 2, 2, 3, 0, 3. We get the average and we calculate the standard deviation of this sample, which we get the average of 2.125, standard deviation of 1.17. Since we are taking a sample, we are really estimating the true average of the Cal State LA students population. So we're to take note that we're estimating. And so we have to make some adjustments and pretty much calculate how imprecise we're going to be with our sample. And that's where the standard error formula comes in handy, where you calculate the standard error. Actually, the standard error is spelled there. Sorry about that. Gosh. And so how it works is that you get the standard deviation of the sample, which we have, divided by the square root of the sample size. And so the standard error ultimately means it indicates how different the population mean is likely to be from a sample mean. How different is our sample mean? Or in other words, it could be how different it's likely that our sample mean is going to be different from our population mean of the Cal State LA students and how many pets they own. And so based on this formula, as you can see, the higher the sample size, the lower the standard error. So we're going to be more precise if we have a sample size higher. But also take note, the lower the sample size, the higher the standard error. So we're not going to be as precise. So it's all part of this formula. All right, so we take this formula. Again, sorry for the misspelling. So we get the standard deviation, 1.17, divided by the square root of 8, which is our sample size. We get 0.44. Now, to get the 95% confidence interval, it is based on this normal distribution, where the middle part, I can't even draw it, the middle part ultimately is going to be, we want to identify this range, the 95% confidence range. We want to capture, like, what's the low point and what's the high point for us to capture 95% of the population. We're going to be 90% sure that the true mean of the population is going to be from this point to that point. It's based on our estimate. And so that 95% confidence is really based on, like I said, the normal distribution, and we arrive to these values, which are the points where it will give us the 95%. So what we do is we take the mean, which we computed before, we take the mean, which is there, and then we take 1.96 standard errors and deduct them from the mean, and then we take 1.96 standard errors and we add them to the mean. So we take one standard, okay, let's say in this case, I'm going to take away one standard error, which is there, and then we take off 0.96 standard errors, and then once we add those together, or once we take away the total amount of standard errors, 1.96 standard errors from the mean, we get 1.27. So if you add them all together, it actually is negative 0.86. You subtract negative, you take away 0.86 from 2.125, you get 1.25. Now we do the same thing, but this time adding it. We add a standard error, which is 0.44, okay, and then we add a 0.96 of our standard error, and we get a total of 0.86. We get the same total, but this time we add it to the mean. We add 0.86 to the mean, add it, and then we get 2.21. So this is the high point of the 95% confidence interval. So now we have our range. We have the low point and the high point, which is in this case 1.27, 2.21. So this is going to be our 95% confidence interval.